Let's take a look and define and describe ions. Atoms that do not have a full outermost energy level go through ionization. They will gain or lose valence electrons to get a full outermost energy level. Now, if you remember, every atom has the goal of achieving 8 valence electrons in the outer shell. If it needs to grab more electrons, if that is easier, then it'll be gaining electrons, so it'll be more negative. If it's like, you know what, I have this 1 extra electron, my outer shell, I've got 8 in the next shell down, so I'll just go ahead and give away that electron, and so it'll end up being positive. Ion, an atom or molecule that has gained or lost electrons and has a net electric charge. So for example here, if we look at all 3 of these individually, we have 6 protons, 6 neutrons, and electrons. So since we have the same number of protons and electrons, this atom is neutral. With our middle guy here, this atom is negatively charged because there's more electrons, remember electrons are negative, than protons. Protons are positive. Since here we have lost a proton, or rather we have a different element, we've got more electrons here as compared to this guy. On the other hand, our last example there, this atom is positively charged. There are more protons are the positive, than the electrons. There are fewer of the negative electrons, and so your atom is positive. So here we have 2 classifications of ions. First we have the cation, and that is the ion with a positive charge. I always remember the cat ion, the T looks like a positive. We also have anions, and these are ions with a negative charge because they have gained an electron. Some people have said they remember this one because it is an anion is a negative ion. So however you would like to remember it. Ionic bonds form when electrons are transferred between atoms. I've always liked this picture here. The name's bond, ionic bond, taken, not shared. Not only is that a fun just little kickback to James Bond, but the fact that it is taken. Those elements are grabbing those electrons fully away from the other atom that they are trying to bond with. They are just snatched right out of their electron shell and taken away. Each atom gets ionized when they bond. They might be ionized by having electrons added, or they're ionized by taking away electrons from their ground state. The ionization energy is the energy required to remove an electron from an atom. The lower the ionization energy, the easier it is to remove the electron. In our example here, the atom sodium has a much less ionization energy than does chlorine. Sodium is saying, here, please just take my electron away. And chlorine, with much higher ionization energy, he doesn't want to lose it, but he says, ooh, yeah, I'll go ahead and grab your electron. The ionization energy increases from the left to the right across a period. Those over here on the right-hand side have higher energy of ionization than do these guys over here. So sodium has much less ionization energy than chlorine. So sodium was ready to give away that electron very easily. Ionization energy also increases from the bottom to the top of each family. So this corner up in here has very high ionization energy. It's very difficult to remove electrons. this little corner over here in the bottom left, it is very, very easy to remove electrons from this area of the periodic table.